Okay, today we will still focus on calculus. I, in particular, will go through questions on kinematics, finding y given dy dx, and we will venture into greater detail for techniques of integration, especially those involving ln and exponential functions. Now, you will see what I mean later. Okay. Okay. Then basically, I'm doing this now. But before I start, sorry, I think there is an error here. Okay, the teacher made a mistake in the solution. So the final solution should not end here because the question asks for equation of the curve. So after finding C and K, okay, you should sub this back into here to get this final curve equation. So this is the final answer. The 1 mark should be allocated here. All right, thank you for highlighting. Now let us start now to go through some more questions involving calculus. Okay, I will again start with this kinematics. Why am I focusing on kinematics? Because there are many examples that I'll give you on kinematics. Kinematics, there are different types. Not say different types, but the S or the V or the A, that function that you get here, right? You have here, it can come in different forms. For example, now it's in algebraic form, right? But it can come in exponential form. It can come in trigo. It can come in other forms, but I will show you one by one so that you know exactly what to take note of for each of these cases. Okay, so if you read the question, those who want to, you can pause the video now and then try out. Okay, this is the question. Now let's start. Okay, importantly, you need to take note, this particle is traveling along a straight line. Okay, they will always travel in a straight line, as I mentioned to you, and it passes through a fixed point O. Okay, so you may want to just label on your sketch this point O with a speed of 0.5. Okay, so it passes through this point 0.5 meter per second. All right, and the acceleration A of the particle t seconds after passing O is this, meaning to say we will start the stopwatch. This concept is very important. We will start the stopwatch only after the particle has passed through this point O, meaning that this point O is the reference point. Okay, and the equation of the acceleration is given by this at any point in time. Okay, not just here at this point O, but any point in time, right? Let's say t equals 5 seconds, you sub in, you will be able to tell the acceleration of the particle. So that's what they mean. Okay, now find the value of t when the particle comes instantaneously to rest. So we know that whenever you say at rest or whatever, instantaneously at rest, then it means that the velocity is 0. But we are not given velocity here, so of course we need to use what we know from this. Okay, I'm showing you this every day so that it gets into your brain. So we have the A, we want to go to V, so we integrate the A. Alright, so that's the whole idea. Integrate this, and of course you know that when you integrate, okay, so it's here, V equals 0. Integrate this. Okay, I'll get this at the t, then t squared divided by 2, you get this, and you must remember to plus c. Okay, a lot of students will forget this. Please remember, you must plus c because this is indefinite integral. Now, after you have obtained this expression, your job is to find out what is c. And if you were to look at the initial conditions means what they give you at first. Okay, what they give you at first, you will realize that when t equals 0, what is your v? So that's this part here. I can use v, we call this v naught. You put a v, then you put a 0 here, right? It means initial velocity. Okay, initial velocity. So initial velocity, when t equals 0, v equals 0.5, right? That's what we are given, right? Okay, so that's what you need to sub in, and then you can get c equals to 0.5, and that is your equation for velocity. And now you can use this concept that you have actually learned, I think 2 days ago, and then you go and find your t. And as you notice here, I reject the negative value because t represents time. Okay, so this is very important. You cannot, do things blindly and then accept both answers. Cannot. You need to reject this and you need to write it out. Okay, so that's all for part 1. Now let's go to part 2. Those who in fact, all of you should you try and do this without my help. You pause the video. Okay, after you're done, then you can check. Okay, now, okay, ready to discuss. Total distance. Distance means you need to. So you write this down somewhere, your SVA. You write this down somewhere on your formula sheet in the exam. From velocity, get to displacement, because displacement will help us to find the distance traveled. Now, how do I do this? I integrate the velocity, okay, meaning this red box that I have here, okay, and then you can get all this. All right, you check whether you can obtain this. Now remember, you must plus C again, but again we are a good school, so if you put plus C here, some teachers may mark you wrong. So you may want to put plus C1, or you can put D or whatever lah. Because this C, right, actually is not the same as this C. Sometimes you may be marked wrong, okay, if the marker is very fussy about this. All right. Okay, so when t equals 0, s equals 0, so your C1 equals to 0. Okay, because this is 0, this is 0, this is 0, this is 0, so of course this is 0 lah. So you just need to state this, your working is done already. Okay, then I box this up again. So you see, if you to just look at it, right, yeah, all these will attract your attention, okay, including the one in the question, okay, because there are many other equations. I don't want you to be confused, so it's good to box up your S, B, and A. Okay, now the next thing is they want you to find the total distance traveled by the particle between t equals 0 and t equals to 10. Okay, now you must be aware that when the particle stop, it is actually U-turning. Okay, now you see, this is this S is a quadratic function. Quadratic function means you will be like that. Okay, so why do I say that the particle actually U-turns? Because, okay, we don't draw this, because it moved to a certain distance and then it U-turned, you went back, you see. So this is where the let's say this S and then this T, ds dt, right, equals 0. The gradient is 0, so that's when it stopped. The V is 0. Okay, the V equals 0. V equals 0. That's why it stopped to U-turn. It didn't stop and then it moved forward again. No, it stopped to U-turn. Alright. Okay, so that is what you need to know. And if you to look at this question, must I have any U-turn or turning point that I need to take note of? There is, right? Okay, because earlier in part 1, you found that instantaneously at rest, you have one timing, t equals to 5. That is the reason why automatically, without the question prompting me, right, I know that I have to find t equals to 5 where it U-turn. Okay, and then I find t equals to 10, then I get the answer. Now you may wonder how I get this answer. Now very importantly, this is what I mean. You need to draw a sketch to help you, okay, especially when finding this part, the distance part. So I've drawn the sketch here already. Okay, now in your sketch, you must, the sketch must help you, so you must label it clearly. So at t equals to 5, you look at my left finger here, t equals to 5, okay, I write here S equals to 7.5, all right, on this we can call it the horizontal axis here. And then down here v equals 0, right? V equals 0. Why v equals 0? Okay, you don't have to label this. I'm just telling you v equals 0 because it's U-turned. Okay, U-turn, and then later when t equals to 10 seconds is at minus 25. That means it's 25 meters away from your fixed point O. Okay, yeah, so we do things by part. Okay, this is how I do it. If you have other ways you're more comfortable with, then you do it your way. Okay, I know that this is 7.5 length, this is 7.5 length, this is 25, right? 25. So I add them up. That's how I got this. Okay, check my answer. If answer is wrong, you amend. Okay, now this is done already. I'm going on to the next question. Okay, the next question is on it's a what we call a hybrid question. It combines 2 or 3 concepts together. Okay, so you read the question. Those who want to, in fact, you're recommended to you pause the video to think about it. Okay, so the gradient, meaning the gradient function is this. All right, and the curve intersects the x-axis at a point P. Okay, so you can give yourself this visual thing. I don't know how the curve look like. The curve may look like that, curve look like that. We don't know, but don't care. You just put a point P here because you need to tell yourself or you need to know that at this point P, right, because it lies on the x-axis, it must have an x value, right? Which means the y value is 0. That means later you must sub y equals 0 into the y equation, not here, because this is not the y equation, right? Okay, so maybe that is what you have to do lah. So when they tell you things like that, it's not for fun. Okay, they tell you this for a reason. Now, given the gradient of the curve at P, okay, gradient here is 1. What does this mean? Oh, you see, class, when I do the question, right, I don't just read and then I just read or I spin my pen. The worst thing you can do is to spin your pen. Don't spin your pen. Spin your pen, you're wasting your brain power. So all your blood will go here, right? Focusing on this pen, okay? You need all the blood you can in your brain now, okay? Now, given that the gradient of the curve is 1, meaning to say this one, dy dx is 1. Oh, if I set this dy dx to 1, then I can find x already, right? So that's what I'm going to do later. Okay, but what I did was I go and integrate this first. Okay, that means I anyhow whack. I go and integrate this to find y, because I know I need to find y, right? So I integrate power plus 1, because this originally was x power 0. Okay, you don't have to write this. I'm just telling you for those who still not very familiar. Okay, then power plus 1 divided by new power. Okay, so you get this. Again, must plus c. Alright, so this is your so-called y and x equation. Okay, the c you need to find. How to find the c? You know, this will help you, you see. You know that your m is 1. Okay, your m is 1. So you sub in. Oh, you can find your x already. Okay, you find your x. Then once you have found your x, hey, remember when you cube root 8, right? It's not plus minus 2, it's just 2, okay? Then you get this. Oh, once you've gotten this, then you have this, you see? So you see how powerful this so-called sketch is? Alright, so when you first attempt a question, you must doodle a bit, okay? Then you ask yourself, talk to yourself in your brain, okay? Then your brain will work. You cannot just be reading the question. If you just read the question, can tell you not much use. Alright? Okay. Now, so that's about techniques. Okay. P, you have found P already. Very good. This is 2. Then what do they want us to find? Oh, they want us to find the equation of the curve. Are we able to find the equation of the curve? We got the x, we got the y. Can put here, put here, put here, then can find the c already, right? So that's what I'm doing. That's all. Okay, so that's for this particular question. Yeah, so I hope you have a clearer picture. Now, let us move on to another type of question now. I need to cover this up. Okay, differentiate this with respect to x. Okay, differentiate this with respect to x. Now, you learned that differentiation is differentiation. I'm trying to look for the notes that I prepared. Okay, differentiation, right, is like that. Okay, when you differentiate this, you get this. Differentiate this, you get this. Differentiate this, you get this. So the other way, right, is integrate lah. Okay. Yeah. So take note differentiate secant. Tangent is secant square x. Then remember that your fruit inside this fruit here, this is the differential, right? The fruit you must differentiate, right? Differentiate, then you multiply. For differentiation, you must multiply. Integration, then you divide. Okay. Now let's move on to the next part. Okay. Those who can all of you try this? Pause the video and try this. Explain whether the curve has any stationary points. Now, if it has stationary point, that means what? Stationary points we always learn, when we were studying for our mid-year, right? We always say a stationary point, then this dy over differentiate whatever this is, you will get 0, right? At stationary point, meaning the gradient is 0. Okay, yeah, so that is something that we are testing you now. So this question, right, combines differentiation, integration, and stationary maxima, minima together. Okay, yeah. Okay, now how do we do this? So do we differentiate this now? Actually, it's already differentiated, right? Yeah, it's already differentiated. So I write here. Then do we set this to 0 and then try to solve? Okay, what I do is I rewrite this as this. Okay, why? Because if you notice, right, the so-called basic units or basic cells, right, of trigo are sine, cosine. Tangent is actually made up of sine and cosine, if you remember. Okay, I've written here. Tangent is actually made up of sine and cosine. Alright, so always try to work with sine and cosine. But of course, sometimes tangent will come in to replace that 2 very neatly. Okay, so I examine this 2. 2 is positive. Okay, and that means 2 is not 0 lah. What I'm trying to say is it's not 0, right? 2 is greater than 0. That means it's not 0 lor. And this cosine, this square whatever thing, right? Actually, it should be greater or equal to 0, right? But it cannot be equal to 0, is it? Yeah, because if it's greater to 0, the denominator is 0, then it's not defined already. Yeah, so can only be greater 2. Okay, so that's 1 point. 2 point, I covered these 2 already. That means I have, like in your bio terms, I have dissected my so-called function. I've examined each one of them already. Okay, and I found them to be greater than 0, meaning to say that they are not equal to 0 lor. So if there's no equal, if they're not equal to 0, that means no stationary point. So that's something you have to be aware of. And by the way, class, for your new syllabus, actually you are the new syllabus people for this current AMATS 4049. You're the first batch of people. They take out a lot of concepts. They take out a lot of concepts. So they may expect you to explain more. That means you will go more in depth for each kind of question. Okay, so that's something you need to be aware of. You need to be able to explain. Alright. Now the next question is this. I hope you can see clearly. You can see why is it like down here, sorry, this is the next page already. The question ends here. Okay, question ends here. Okay, you may try. Okay, now let's go through. You may try like that. This is a full question. Okay, now the first part, very simple. They ask you to show. Show means they are guiding you already. So you work with the end in mind. So let me do it. Differentiate sine is cosine. Okay, then I must differentiate the fruit, right? The fruit, this fruit, when I differentiate, I'll get the 2. So remember not, differentiation must always multiply. Integration, then you will divide by the fruit. Okay, later we'll go through. Then you differentiate 2x, you will get 2. That's all. That's all. But I mean the differentiation, that's all lah. You would have gotten 1 mark for doing this, but how do I get from here to here? Now that is when you need to be very familiar with the double angles. So for this series of videos, I'll be focusing a lot of calculus, trigo, so that you don't forget your trigo. Okay, now how do I get from here to here? So you use a double angle. If you refer to your formula sheet, by now if you have not internalize it, right, you should use this holiday to internalize it. Otherwise, you spend a lot of time checking which one to use and all that, waste time. Okay, why did I choose this? Remember, there are 3 different identities for this cosine 2x double angle. I choose this because I want this cosine square. Okay, then when you manipulate, you will get this. So your A is 4. But in this question, they didn't ask you to find what A is. They just want you to write in this form. So you just leave your answer like that. Okay. Now, hence means you use this result. So what did I teach you? Use this. Don't care what they want here. Not say don't care lah. I mean, you don't start from here. You start from here and go to here. Meaning, integrate this end result, right? I should get the original expression. Yeah, that should be your starting point. Okay. Now, of course, if you do look at the question, they have limits. Limits, okay, from pi over 2 to pi, meaning to say it is definite integral, got a definite answer. So I follow them. Whatever they write there, I follow. Then I put a box here, pi over 2 to pi. Okay, later you throw this here, and then minus. Throw this here. That's all. Okay, so that's what I'm going to do. Okay, this step is important as a start. Alright, but you need to manipulate to what they want. Remember, I made a mistake. I think first lesson I said you must always write this. So this is what I need to do. So I don't want the 4, right? This 4 has to go. How to go? Divide by 4 both sides. So it end up here. Okay, then you throw this in, press calculator, and you get the answer. Now because they want I want you to practice giving your answer in exact form, so I will try to design the question in exact form. Alright. Sorry. Okay, so please try pressing the calculator, okay? And please take note, what mode must your calculator be? Your calculator must be in the radian mode. Alright, otherwise you won't be able to get the answer. Okay, so that is all for this particular question. Let's move on. Okay, I try to cover more today because I'm hoping to move to a PowerPoint presentation to see whether you all can see better or you prefer that PowerPoint better than this. Okay, now one more trigo question. Prove that cosine 3x. Okay, so you see, as I said just now, whenever possible I try to throw in trigo. So there's trigo proving here. You can try now. Okay, pause the video, try now. Okay, then okay, now you have finished it. Okay, now those of you who tried just now and then you think that this is more complicated, you will find that it's very difficult to prove this to this. Very difficult. Alright? Because actually if you look at these two, right, if you think carefully, this is the one that you should start with. Why? Because as I said, when you want to do proving, right, you always attack the side that is like can be like it's more complicated, that you can break down. Remember, destroy. So this thing you can destroy. This to get from here to here, right, you actually have to build. You have to build things to come to here. Why? Because this argument is x, this argument is x. So it's very difficult. Whereas this is 3x, you can split it into 2x plus this. Then use your formula sheet to help you. But actually you should know cos is cos. Then the cos you must change sign, right? Minus sine of this, meaning this. Okay, I'm talking about this. If you don't know, check your formula sheet. And please, why I don't really like you all to use the formula sheet, because you will tend to write this as A, because in your formula sheet, right, it's written as A. So in your mid-year, quite a few of you actually wrote as A, but we mark very linearly, so we just give you the mark. Okay, so be very careful. But having said that, if in the exam you cannot remember the formula, the identities, right, please refer to formula, okay? Okay, now, after I've done this, you see, my aim is to change the argument all to x, you see? So I change. Why I choose cosine? Okay, because the result is cosine, okay? But this one, I have no choice, you see, this fella, I have no choice. Okay, I have to have sine, but don't worry, because later, sine square, I can change to 1 minus cosine square. Again, your identity, okay, then you'll get this. Alright, I think this is pretty straightforward, except those who are weaker in this topic, you can ask me if you're not sure, okay? Now, you may want to pause the video and then try this part. Okay, now, very simple, start here, again start here. Okay, start here, meaning this question, right, start here. You integrate this, you should get this. Alright, you start like that, you won't go wrong. Okay, I'll show you everything. Okay, I purposely left out the limits because I want to go through with you how to do it. So the limits, you don't bother too much about it first. You just know that you integrate this, you will get this. Okay, now then you put in the limits. Pi over 6, pi over 2, then this must be pi over, always write the bottom first. Pi over 6, then pi over 2, okay? Then what do? You see whether this is exactly what you want or not. Oh, it's not. Because what you want is only here. Meaning to say you have to slowly remove all these people. But the good thing for this particular question is, oh, sorry, I already put in. The good thing for this is you throw in this, minus you throw in this. This whole thing you press calculator is 0. Remember, again, calculator mode must be radian mode, okay? Radian mode. Okay, now, we only want this, you see? We only want this. So, this fella will stay. You see, this fella stay right until the end. The 4 is the last to change. The 4 is the last to change. Can you see? Finally, then divide throughout by 4. But this fella, okay, this fella, you see, I can actually, you see this integral is made out of this minus this. I can actually split it up into this, okay, alone, then this integrate this alone. I hope you know what I mean. This one you integrate on its own with respect to x. This one you integrate on its own with respect to x. You can throw the 3 out, not a problem. The 3, as I always say, is just a doggy. But now we want to bring it over so-called to the other side. So you see, this fella has come over to this side already. Now when I integrate cos, alright, you can write this on your formula sheet. Integrate cos, you look here, okay? Look here. Don't look here. If you want to integrate cos, you look here. Oh, integrate cos. Integrate cos is sine. That's all. No need to change any sign. No need to change any sign. Meaning to say, whatever sign is here, you follow. But of course, when you bring over here, it's plus already, so nothing to do. Nothing to change. That's what I mean. Okay, then you throw in, then you can get the answer. Exact answer. Okay? Yeah, so that's what I mean by exact form. Alright, okay, so that's all for this particular question. Next. Now, differentiate this one. Okay, this question onwards, right, is about techniques of integration. Okay, so this part here, you may want to pay close attention because it's not something new but it's something that I taught like maybe 2 months ago, so you might have forgotten. Okay, so when I differentiate this, we start with differentiation first, because differentiation always is the reverse process of integration. A differential exponential function, very simple. Okay, exponential function, the power or the index is another function. You see, 2 minus 3x is another function, right? So when I differentiate this, What I see is what I get, but I must multiply by the derivative of this, correct? Hope you still remember this. Okay, now I'll get this, all right? And I'll get this. So that is all for differentiation. Okay, but now, if I were to ask you to integrate, then what would it be? For example, I ask you to integrate this, integrate this, okay? I should get back this, right? Okay, now let's see how we do it, Very simple. This doggy is just a doggy, minus 3. Then this one, just leave it as it is because all we need to do is to differentiate this and then divide. Remember, differentiation is always multiply by the differentiated fruit. Integration is always divide by the differentiated fruit. That's all. And then you just need to plus C. Okay? Because originally, of course, for this particular question, I know that the number here is plus 0. But for other question might be plus 3, plus whatever, we don't know. So you must always plus this constant. Okay? Arbitrary constant. Okay, then you rewrite nicely, you get this, which is the almost the same as this, except we have a plus C. Alright, so that is all. Now let me do another example before we move on to the last thing that we are doing today. Now how much time I have left? Okay, it's 10. Today I go pretty fast. Okay, now this 4 over E3 whatever, right? Okay, to differentiate this, as I mentioned, right, don't go and use blindly quotient rule. Don't. Okay, because for this particular question, you bring it up, right? It'll be a very easy expression like this, okay, which you can easily differentiate. So how do I differentiate? Whatever you see is whatever whatever you see is whatever you get here. Then you differentiate this fruit, which gives you 5. Then you just multiply by 5. Okay, and then you have 20. That's all, finished already. Okay, so that's differentiation. What about integration? I integrate this now. How do I integrate this? Okay, let's say I ask you to integrate this now. Similarly, don't work with this kind of expressions because there aren't what we call quotient rule for differentiation. Don't have. Okay, so what do? Again, bring this up. That means you're doing makeup you're making it simpler. You're doing it in a form that you are familiar with, like that. See, you're familiar with this one. How to integrate this? Whatever you see is whatever you get. Write down exactly. Okay, but because this is integration, so you got to differentiate the fruit, which is 5, divide by 5. That's all. Then you plus the C. Okay. Let me remind you. Once you start to integrate, this integral symbol must disappear. Okay, like here. Once you start to differentiate, this thing must disappear. Okay, but if you are just doing makeup here, right, you have not done any differentiation, this must stay. This must stay. Okay. Now next. Okay, no more already. No more for here. Okay, now we go to the last thing that I want to go through with you. I hope the pacing is just nice for you, not too heavy or what. Okay, now, for example, I give you this. Then ask you to differentiate. Ln function, very simple, right? We just revised, I think, yesterday. It's just 1 over this whole thing. Then differentiate the fruit times the fruit. So it's just like that. Finish already. Alright? Now, what if I were to ask you to integrate this? Now, you see, if I were to ask you to integrate this, integrate 5 over 5x minus 3, right, with respect to x. Okay, if you were to bring it up, like if you remember what I said, right, rewrite it in the form that you are familiar with, then you get minus 1, right? But then you find that you have a big problem already for this kind. Why big problem? Because you know, we just learned that day, right? you need to, for this kind sorry, this is 5. For this kind, right, you need to differentiate the fruit, then divide the fruit, right? Because for differentiation, you multiply by the differentiated fruit. So for this one, you must divide by the differentiated fruit, okay? But now we have a problem. The problem is that when I do my next step, which is plus 1 to the power, then divide by the new power, I find that I'm actually dividing by 0. Which is not defined, right? So you cannot do this way for this kind of questions. Then you ask me, then how? Then you go back to this question. When I differentiate this, I get this, right? Then how come when I integrate this, it's not defined? Yeah, because when you integrate this, right, you must write it as, you must be able to recognize that once this is power 1, right? Once the denominator, the whole thing is power 1, then you integrate it, right? It automatically, right, is a ln function. It's a ln function. Okay? But how do I do it? Okay, the actual way is that whatever the denominator is to power 1, right? You write it as an argument here. Okay? Then you differentiate the fruit. We call this the fruit, which is 5, right? You divide by the 5. Remember, integration is always dividing by the differentiated fruit. Okay? That will get rid of this, and you will end up with this, which is the original expression that you have. Okay? Now, let me go through another example. This one, I show everything. Okay? You see, differentiate this, or that everybody knows is this, right? Your mid-year, you learn already. But if I ask you to integrate this, then you bring up power minus 1. You bring up power minus 1, then you plus 1 to the power, then got problem already. Correct? So you cannot do it this way. You cannot do it the algebra way. You must be able to recognize that when it's denominator down here power 1, right? Power 1, then you want to integrate. You want to integrate, right? Sorry. It's actually ln of this. This will be your argument. Okay? Yeah, then of course you must plus C. Alright, we will do one more example. Okay, how about this? Differentiate this is just 1 over this whole thing, right? This argument throw downstairs. Then differentiate this, you get minus 5. That's all, right? Okay, but if I ask you to integrate this, what do? Recognize that the denominator has power 1, so you write this whole thing as the ln function. That means it becomes your argument. Alright, this doggy stay where you are, stay, okay? But you must differentiate this, which is minus 5, throw it downstairs, you will find that you end up with this. That's all. Okay, you must be familiar with this. This in the exam, if you are not thinking properly, right, you probably will be stuck with such questions. Okay, now I'm going to give you one that is of a higher level of difficulty. Okay, you will encounter this same kind of question in the pop quiz. All right, now how do I do this question? Now you take a look. Oh yeah, denominator, power 1, right? That means this whole thing power 1. If I bring up there'll be problem, correct or not? So power 1 I bring up got problem. So I know it's a ln problem. It's a ln thing. But then I have a problem. And what is the problem? The problem is that ln 3 minus x, right? Okay, then I divide by, then I write the x here, is it? Right, x here. Then I write minus 1 at the denominator, then I plus c. Okay, you will find that this is wrong. Meaning your answer when it comes out like that, right, is wrong. Why wrong? Because if I were to differentiate this, right, I will not be able to get this. Okay, then you ask me how. You see, the previous question, right, is different from this particular question, you know. The previous question, you see, previous question when I differentiate the so-called the argument here, or the fruit, right, I will get a very nice number. And the numerator only has number, no x involved. So there's no problem. Okay. Now you see, you differentiate the so-called denominator, right? You get -1. But there's an x here. So your this x is not taken care of. It will be popping out here, and then it doesn't tally with this. You know what I mean? So then you ask me, then how? Yeah. Is it question set wrongly or what? No. Question not set wrongly. Purposely set like that. Okay. To stretch you a bit. So how do we do this kind of question? Now very simple. What you do, right, is you see, doing makeup, very very important. That's why the ladies, they always do makeup, to cover up blemishes. So this is to me something I don't want, right? So what do I do? Very simple. The only way I can get rid of this x is to photocopy exactly the denominator onto the numerator like that. Then you say, like that can right, equal sign, that means this equal to this, but this not equal to this, what? Yeah. So that's what I mean by do makeup lah. So you see, 3. There's no 3 here, what? Then you go to -3, 3 minus 3, no more, right? Yeah. There's no number here. So this can be equals to this minus this. Yeah, this 0 here, Yeah. But now the x, the x here, is not equal to minus x, what? Then how? Never mind, I put a minus here. You see? So I put a minus here, then minus times this minus become plus. Very good. Same. Then this -3 plus 3 also 0. Okay. So this is equivalent to this. They are the same. But what is the purpose? Okay, so I write here. I left blanks for me to write. Okay. I repeat, okay? The whole idea is like that. Photocopy whatever you have downstairs. The denominator, photocopy. Why? So that becomes 1 minus this. Okay? Later I show you what I mean. But the whole idea, right, is to photocopy so that your x will disappear. This is a very powerful method which you will use next time in the at higher level. Okay, now you see, your x is not 3 minus x, what? Yeah, then never mind. We go and -3, then same already, what? But not the same as you. I'm positive x, you're negative x. Okay, now then I put a minus, happy already. Yeah, we're okay. We're all happy already. So now we see what is so great about this method. This method allows me to say that this divided by this is -1, right? Okay, I bring it in. -1. Okay, then -1 times -3 times -1 here will give me 3, right? So 3 over this. Then now I can do already. Now I'm back to my same old story. You see? So let me repeat. I think some of you probably don't understand why I need to do this. Now you see, when I have 3 minus x at the denominator, when I differentiate this so-called fruit, I get -1. That means I get a number. If I have a number here, I can only have a number here, then it's a very nice long function. Being cancelled off, the numbers all cancel out. I show you everything. Okay, but the problem just now is I have an x here. I differentiate the denominator, I have -1, but I have an x here, so they don't nicely cancel out, you see? Yeah, so this is what I need to do, This makeup here is what I need to do in order to solve that problem. Okay? Now, finally, this minus and this plus will become minus, and that's your answer. Now, if you don't believe me, I'm running out of time, so I can't show you. You go and differentiate this, right? Okay, then you combine these two together. You go and differentiate this, then combine two together, right? You will get this. Okay, go and try. Wait, let me just do. I thought I want more. Where's my one more? Okay, Yeah. Sorry. Okay. Okay, sorry. Okay, yeah, let's say I give you this question. How do you do this question? Okay, you may want to pause the video and then try on your own. Okay, let's say you finish trying already. Okay, I quickly do. Okay, time is up already. Okay, now firstly, you notice when I differentiate. Okay, firstly, you'll notice that, oh, this is power 1. Oh, that means got problem. When you bring up is minus 1 plus 1 divided later you will divide it, right, is 0. Cannot. That means this is a ln thing. That's the first thing. But then now you differentiate this, right? Oh yo, it's minus 2. Minus 2, if it's just like that, we can manipulate, no problem. But if there's an x here, then you are not settling this x, you see. This x won't go away. So you have to make it go away now. So what do you do? Photocopy. Okay, photocopy this thing. Very powerful, this photocopy method. Okay, so what I do is I have not integrated yet. Okay, I'm just doing makeup, you know. So what do I do? Photocopy exactly. Don't think at all. You just quickly photocopy. This first part, no need to think one. Just photocopy. Okay, okay. Then now you must try, because now you are saying this equals to this one. But are they equal? No. Why? Because 5. Okay, we do the number with number, algebra with algebra. Okay, you must know what's going on. So 3 is not equal to 5. What? How to make this 5 become 3? You minus 2. You see? 5 minus 2 is 3. Yeah, the number settled already. Then the, what you call that? The algebra here. Oh, already settled. Okay, this question is simpler than just now that one. Alright, okay, now what is the point of doing this? The point of doing this is that this over this is 1. Okay, and then minus this over this, you can actually integrate and then get a very nice ln expression. Okay, so that's what we are doing here. Okay, so integrate 1 is what? Actually, this is x power 0, so it's 1x. Like that. Okay, and then this one, whatever you see right here, my minus 2, right, just right here. This fella, change it into a ln, so this becomes the argument of the ln. Differentiate this divided by this. Then these two will cancel, become wrong. Sorry. Yeah, like that. Okay. Yeah, so we will end here today. Let me see. Okay, I think I did ask you to do the pop quiz yesterday, right? We will discuss another day. Okay, we will discuss another day. Those who are interested, you can do pop quiz 2 also. That means pop quiz 1 we have finished discussing. Pop quiz 3 yesterday I asked you to discuss, but I won't be going through yet. So 2 and 3 you can do probably next week. Then I will go through. Okay. Yeah. Thank you.